Alright, gradates. Welcome to chapter 3. This chapter is all on exponents. We're going to start off simply by looking at some notation and theory, as well as your 4 laws that you are going to be learning with regards to exponents, just briefly, and then we're going to dive into each law and how they work on their own. So firstly, let me grab my little laser pointer here, and I want to talk about the different definitions. What is an exponent, what is a power, and a base, because that is what we are going to be referring to most often. So firstly, this whole thing, a to the power n, even if I make it 2 to the power 3, the whole thing together would be considered a power. The little number at the top is known as the exponent, and the number at the bottom is the base. Now you will see there big in red, I've made a rule here for you to keep in mind that the bases do not change when applying the exponential laws. There is one exception to this rule, and that's over here. Anything to the power 0 becomes 1. So even if I have 200 to the power 0, that will become 1. So in essence, that base has changed. But any other time, our base will not change. Okay, so just quickly again, number at the top is the exponent, number at the bottom is the base, and together as a pair, they are known as a power. Okay, I'm going to come back to these notes. I first want to talk about what an exponent actually is. And here is the theoretical side of it. Let me get the law out of the way so you don't see that now. This is the theoretical side of it. If I've got a base a to the power n, that means the base is simply being multiplied by itself an n amount of times. So as an example, move that even further. As an example, if I say 2 to the power 2, it's just going to mean that the base of 2 is multiplied by itself twice. If I say 2 to the power 4, same thing, but now the base of 2 is being multiplied by itself 4 times. And that's how we can continue. The exponent is going to tell you how many times the base is being multiplied by itself. That is what an exponent does. Okay. Now these laws are here. I'm not going to touch on them now. They are here as a revision part. As I said, this first part is just a definition and the laws. So this is just a place where you can see all 4 the laws. Okay, but we're going to attack them one at a time, and then I'll come back to this. I just want to make special mention of the little note here on the side. These are just special cases to keep in mind, and that's going to be that, again, anything to the power 0 will always equal to 1. 1 to the power anything is equal to 1, so I can raise 1 to any exponent, and it will still equal to 1. And then these last two are very similar. If I've got a negative power, if it's a whole number for a base, then we can move it below the division line and change the powers or the exponent's sign and turn it positive. Same goes for if I have a negative exponent in the denominator, it can move up above the division line and it can turn positive. This would still technically be over 1, but again, as with fractions, we don't write that. Same as how this one seems to just appear, but if you have nothing in the numerator, you will always have 1. It's not going to be 0. Okay, so that is just a brief introduction on what exponents are, and we're going to jump over now into law 1 in the next lesson and see how we use that.